NASA's Juno mission is truly unveiling Jupiter's most profound, hidden secrets, presenting us with stunningly detailed views of its poles, hinting at a surprisingly fuzzy core, and even capturing what appear to be snowing clouds. After its daring arrival at Jupiter, Juno successfully executed a critical maneuver, inserting itself into a unique polar orbit. This meticulously planned trajectory has allowed the intrepid probe to spend the past year meticulously gathering an unprecedented wealth of data as it repeatedly circles the largest planet in our solar system. So, with all the scientific anticipation and the immense fuss involved in launching this sophisticated orbiter across vast cosmic distances to reach Jupiter, what astonishing discoveries has it actually made? Was every ounce of effort and every dollar spent truly worth it? Just glance at a few of these absolutely breathtaking images, and then tell me what you think. However, it's crucial to remember that Juno is far more than just an incredibly expensive, high-definition camera. It's a comprehensive scientific observatory, diligently performing several distinct scientific experiments, and the initial results have already begun to fundamentally reshape our understanding of not only Jupiter, but the entire solar system. So what exactly has Juno been up to? Its orbital path is remarkably distinct, a highly perpendicular trajectory that brings it incredibly close to the planet during its closest approach, skimming a mere 4,200 kilometers, approximately 2,600 miles, above Jupiter's swirling atmosphere. From this exhilarating low pass, Juno then slingshots outward to its furthest point, soaring over 8.1 million kilometers, about 5 million miles away. Each complete orbit, this daring cosmic dance, takes a painstaking 53 days to finish, and by the scheduled end of its primary mission, it will have completed 12 such intricate loops. Yet, given that Juno remains in exceptionally good health, there's growing optimism that its groundbreaking mission could very well be extended, promising even more profound discoveries. One of the paramount reasons Juno plunges so incredibly close to the colossal planet is to strategically navigate and ultimately evade Jupiter's notoriously powerful and deadly radiation belt, a veritable cosmic gauntlet. There exists a slender, almost imperceptible gap, a safe corridor, precisely where the planet's main atmosphere ends and the ferocious radiation belt begins, and Juno has been engineered to expertly exploit this narrow window. Initially, there was considerable concern among mission planners that Juno might still receive a significant, potentially crippling dose of radiation from the peripheral parts of the belt it inevitably brushes against. Yet, in a testament to brilliant engineering and a stroke of cosmic luck, the radiation levels encountered in these zones were actually 10 times lower than anticipated, a fantastic boon for the probe's long-term health and operational longevity. To truly appreciate this achievement, recall the unfortunate fate of the previous Jupiter probe, Galileo, which was quickly rendered unusable by Jupiter's relentless radiation because its orbit, less fortunately chosen, cut directly through the heart of the intense radiation belt. Therefore, ensuring Juno's radiation avoidance was a top priority for the meticulous mission planners. Another invaluable benefit derived from Juno's daringly close proximity to Jupiter during its periapsis, closest approach, is the absolutely unparalleled detail in which we've been able to scrutinize the gas giant. The very first images beamed back, particularly those showcasing Jupiter's enigmatic poles, literally took people's breath away, defying every preconceived notion. Some observers even ventured to say that even seasoned planetary scientists, intimately familiar with Jupiter, might not have recognized the planet from these radically different views. Simply put, no one was prepared for the stunning, unexpected vistas Juno revealed. What you are witnessing in these initial, groundbreaking images, particularly around Jupiter's south pole, are not the familiar, serene bands, but rather a chaotic yet mesmerizing array of numerous, titanic cyclones, swirling in a cosmic ballet of unprecedented scale. What is truly remarkable is how profoundly different the planet appears from the iconic, horizontally striped patterns we have long grown accustomed to seeing on Jupiter. However, it's worth noting that to bring out the intricate details in these initial captures, the contrast of the image has often been digitally enhanced. A natural, unassisted eye would perceive something far more subtle, perhaps resembling a muted, swirling canvas. This particular stunning image of Jupiter's pole is not a single shot, but rather a meticulously crafted mosaic composed of several individual images, ingeniously stitched together to provide a comprehensive view of the entire illuminated side of the planet during its Jupiter flyby. The North Pole, by contrast, doesn't offer quite as clear or dramatic a view, as it currently experiences its Jovian winter, with certain sections of the pole shrouded in perpetual, unyielding night. Beyond its extraordinary photographic capabilities, Juno also possesses the remarkable ability to pierce deep beneath Jupiter's visible cloud tops, employing a highly specialized microwave radiometer, MWR, an instrument designed with meticulous precision specifically for this spacecraft. Utilizing this marvel of technology, scientists were able to precisely map the distribution and sheer quantity of ammonia within Jupiter's turbulent atmosphere. Yet, what they certainly did not anticipate discovering was this distinctive, perplexing band of ammonia encircling the equator, depicted vividly in orange within this composite image. This colossal pillar of ammonia plunges dramatically downward from the uppermost cloud layers, extending over an astonishing 350 kilometers, approximately 217 miles, into the atmosphere, pushing the very limits of what the MWR is capable of observing. Scientists are, understandably, profoundly puzzled by this anomalous finding, as their long-held models and predictions suggested a relatively even, well-mixed distribution of ammonia throughout the entire planet. They theorized that the various gases within Jupiter's atmosphere would simply intermix uniformly, or at the very least, adhere to the established, familiar band pattern of the planet. However, Juno's irrefutable results stand in stark defiance of these expectations, indicating a far more complex and dynamic reality. This striking discovery vividly demonstrates just how incredibly variable and tumultuous the planet truly is beneath its deceptively calm, visible top layer of clouds, revealing a churning, unpredictable world beneath. Previously, for decades, scientists had confidently predicted that Jupiter harbored a dense, solid core at its heart. However, armed with Juno's cutting-edge gravity science instrument, the data now strongly suggests that this core is far more hazy or fuzzy than they could have ever anticipated. This groundbreaking revelation could have monumental implications, potentially implying that Jupiter's core is not, in fact, solid, or perhaps it has partially dissolved, or even, most radically, that it doesn't exist as a distinct, solid entity at all. It may take a significant period of time, perhaps even years, before we can truly unravel the profound truth behind this pivotal point, as all the meticulously collected microwave, radio wave, and magnetic field data must be painstakingly combined and analyzed to construct a more comprehensive, definitive picture. And speaking of the magnetic field, the results transmitted from Juno regarding this fundamental planetary characteristic also delivered a considerable surprise to the scientific community. In certain localized regions, Jupiter's magnetic field was observed to be unexpectedly stronger than predicted, while in other areas, it registered as significantly weaker. These irregular, patchy variations further suggest that the magnetic field might not be solely generated within a conventional, solid core, but rather originates higher up, perhaps within the exotic, conducting metallic hydrogen layer that lies above the conjectured core, giving rise to its distinctly irregular, asymmetrical structure. The magnetic field, as we know from earthly phenomena, is the grand orchestrator of spectacular aurorae, and Juno, equipped with a specialized infrared aurora mapper, is providing us with an absolutely unprecedented, breathtaking view of Jupiter's majestic aurorae, unlike anything we've ever witnessed before. The prominent central band shimmering in this captivating animation represents the planet's main aurora, a colossal crown of light. Meanwhile, the smaller, constantly moving point to its left is a direct consequence of the closest of Jupiter's 4 Galilean moons, Io, with the ethereal tail trailing behind it being the ghostly remnants of Io's incredibly dynamic orbital motion and its constant interaction with Jupiter's powerful magnetosphere. The brilliant whites and vibrant greens visible in this mesmerizing image are indicative of high-energy ions relentlessly striking Jupiter's ionosphere, raining down from the vast expanse of space. Intriguingly, the reds, which appear even deeper within the planet's atmospheric layers, could potentially signify ions originating directly from the planet itself, a truly profound possibility. If this hypothesis proves to be accurate, it would represent a groundbreaking discovery, a phenomenon never before observed in any planetary aurora. It's important to note that most of this critical data collection isn't continuous. Instead, it takes place during incredibly brief, intense windows, lasting only a few precious hours per orbit, as Juno rapidly whizzes by the colossal planet. During these fleeting yet intense periods, all of Juno's sophisticated instruments, including its high-resolution camera, work in unison to collect as much invaluable data as humanly possible. This remarkable video is a captivating time-lapse sequence, beautifully illustrating Juno's exhilarating approach towards Jupiter's northern hemisphere, only to then gracefully depart again as its gaze shifts towards the planet's equally enigmatic southern hemisphere. And this particular image, a masterpiece of compilation, is a collection of all the individual frames that were meticulously used to construct that mesmerizing video. As Juno makes its dramatic approach toward the planet, you can distinctly discern the colossal storms swirling with unimaginable ferocity around the North Pole. Gradually, as the probe continues its journey, the expansive view majestically shifts, bringing the mid-latitudes into sharper focus. Zooming in even closer on some of these incredible shots, we can clearly observe the classic, familiar swirls and intricate patterns that we've come to expect on Jupiter's surface. However, upon an even closer, more discerning examination, a new detail emerges. These distinct, brilliant white specks scattered across the cloud tops. These intriguing specks are, in fact, towering clouds composed of either water or ammonia ice, their elevated presence clearly confirmed by the distinct shadows they cast upon the layers beneath. These icy behemoths are situated much higher in the atmosphere than the surrounding, more pervasive cloud layers, creating a kind of atmospheric topography. And while they might appear deceptively small in the vast context of Jupiter's immense scale, these individual cloud formations are actually over 50 kilometers, approximately 31 miles, wide, a size that dwarfs many terrestrial cities. It simply serves as another powerful reminder. Jupiter is just truly, astonishingly enormous. Once your eye registers them for the first time, these unique white ice clouds begin to appear ubiquitous, suddenly visible almost everywhere you look, further highlighting the dynamic, multi-layered complexity of this incredible gas giant. Imagine, for a moment, the utterly frigid, biting cold temperatures that must grip the Jovian atmosphere at these extraordinary altitudes, precisely where those majestic, swirling cloud formations reside. And because these enigmatic clouds are unequivocally confirmed to be composed of crystalline water ice, unlike the ammonia and ammonium hydrosulfide clouds found deeper down, it leads us to a truly mind-bending possibility. It could, quite literally, be snowing on Jupiter. Can you picture it? Microscopic ice crystals, perhaps glistening faintly, cascading through the colossal gas giant's upper reaches, a celestial blizzard on a scale unfathomable to our terrestrial sensibilities. Remarkably, despite decades of telescopic observation and multiple intrepid spacecraft missions, we are still continually unearthing a wealth of new knowledge about our gargantuan gas giant neighbor. It's truly astonishing, isn't it? One might naturally have assumed that given its unparalleled proximity and sheer immensity, making it the most easily observable and largest gas giant in our solar system, we would possess a rather comprehensive and robust understanding of its intricate atmospheric dynamics, its mysterious internal mechanics, and its powerful magnetosphere. After all, it's been a focal point of astronomical study for centuries. However, it has become abundantly clear, especially with the groundbreaking arrival and ongoing mission of NASA's Juno spacecraft, that our journey of discovery is far from over. Indeed, it seems we still have an enormous amount to uncover and learn. Juno's unprecedented, polar orbital passes have been peeling back layers of Jovian mystery, revealing complexities we never anticipated. Furthermore, it's not just a matter of finding answers to existing questions. There are very likely profound, fundamental questions we haven't even conceived of yet, questions that are only now beginning to emerge from Juno's revolutionary data, let alone having any semblance of an answer. The universe, it seems, delights in humbling our assumptions. A heartfelt thank you for tuning in and watching. Your unwavering support, your clicks, your comments, your shares, they genuinely mean an incredible amount to me and fuel this passion project. I truly apologize for the recent hiatus. It was an unavoidable period as I was deeply immersed in a significant amount of demanding academic work for my university studies. But now, thankfully, I have the entire summer off, a glorious stretch of time, and I am absolutely chomping at the bit to get some fantastic new videos out to you guys. I've got some exciting ideas brewing, and I can't wait to share them. So, if you're keen to catch these upcoming explorations and don't want to miss a single one, be sure to hit that subscribe button and join our growing community. And if this particular type of content, these deep dives into scientific wonders and astronomical marvels, truly captivates your imagination, then please do me a huge favor and give the video a thumbs up. It's an invaluable signal to me, letting me know precisely what resonates with you the most. Thank you once again for your incredible engagement, and I eagerly anticipate seeing you all next time.